All right, we're back for the long-awaited part 2. So let's reviewing what we had from part 1. We had some basic functionality for instantiating beat targets. All right, classic Unity taking 20 seconds for an almost empty project. So we're able to register hits and have them disappear. All right, let's add some sort of timing mechanism. So the way we're going to do that is just with some basic sprites. So we're going to have a circle here, and we're going to have another circle. So 2D object, sprite, circle. And if you don't have it, all of the stuff is in the 2D animation package, which is in the Unity registry, so it should be fairly easy to get. Now for one of these, we can actually use a sprite mask. And let's remove this sprite render here. Now, the cool thing about the sprite mask is the interaction that objects have with it is actually defined inside of the sprite render here. So you see there's a mask interaction where you can do visible inside mask or visible outside mask. Okay. So I guess it's this little guy right here. Let's give it it doesn't come with a sprite by default, so I think it's going to need this sprite in order for it to work. I think, okay, we can just define this sprite right here. You might not have this sprite, so the way you get it here is if you don't have the circle, I'll show you mine is just in assets. I actually just got this from the 2D animation package. For some reason, it doesn't let you access it from outside. So what you can do is if you click the circle here inside of the original sprite render that we created, we can just copy it from this location, Control C, Control V into here, and now it allows us to kind of access this. And then once we drag it in here, we can see the sprite mask kind of start to work. Like that. Okay, so let's just center this, and we're just gonna increase the scale of this outer one to 1.2, 1.2, 1.2. I guess, okay, it's still, okay, see, that doesn't make sense because the inside still gets scaled. So what we have to do here is, let's put this back in the origin. We drag this out. Now you can see here it gets multiplied through by its parent. That's why its scale increases to 1.2, 1.2. So we scale this down to 1, 1. And I guess now you'll see that the scale got multiplied through by the 1.2. So, okay. I guess this works. So we have the parent at 1, 1, 1 with the sprite render in the circle, and we have the inside scale at 0.83 of the sprite mask. Now we can also add, I'm going to add another 2D object just to kind of make the inside beat here. So let's do that. Let's give it the same scale as this one for X and Z. Now for this one, I'm going to do mask interaction visible inside mask. Let's change the color here. All right, perfect. So now we have something that's inside our mask, and this is probably going to be similar to our old prefab here. Let me try to get the color right. I think it's a little lighter. All right, that's pretty close. Okay, and then we can make our outside color whatever we want. Make it green maybe. Okay, cool. So now you can see it still doesn't quite work because when we change the scale, it's scaling the inside mask too. So I think the best thing to do here would be let's flip the hierarchy. Let's drag the mask out, and we're gonna make our components children of it, so we can control them separately. Okay. And we still have the same problem where we're not getting that hollowed out effect that we want. So let's take this back out. And we'll just rename these so it's clear here. We'll just call this our mask. We'll call this the fill. And we'll call this our beat border, maybe. So I think really what we want is we kind of want, let's take the fill out for now. Okay, so now we have the, as you can see when I scale this up, we kind of get that effect where we can shrink this down and the mask grows with it. But the fill doesn't change. So if we drag this as a child of this, we should be able to get all of the effects we want. Because now the parent isn't affected. And we can scale all this stuff up as we wish. I'm just going to standardize these scales real quick. Right, there we go. Let's do this at 1.2 maybe. Okay. Good. Great. So this is our final configuration. We've got the fill as the parent with a sprite renderer, then the beat border as a child with a sprite renderer, and then we've got the final child, which is the mask. Okay, so now let's go to our script. And what we really want to do here is, instead of just changing the color, well, let's just see what this looks like before we move on. So first, let's set this as our new prefab. We can call it beat. And let's just drag this prefab we just made into our beat spawner script from the first episode. And let's see what we're working with here. Okay. So as you can see, it's no longer fading, probably just because it's not able to, yeah. It's not able to get the sprite render anymore. Or it might be, but it's just lerping one of them. Let's pause. So we got this sprite render, which might be fading out. Lerp, you'll return. Let's see. Oh, okay, right. We never assigned the hit script to our prefab. Yeah, that's important. So let's assign that. And now, probably don't need this anymore, so I'm just going to set this inactive. I'm probably only going to notice the outside change. Okay, there we go. Okay. So this is not exactly doing what we want, so let's fix it. So instead of changing the scale, we want to change the color and the scale. And we want to change the color of the border, not the fill. Let's fix that. So here, instead of just grabbing the get component sprite render, I'm just going to make a public sprite render. Let's call this the beat border. Just so it's very explicit and we're not just like guessing at what we're doing here. Okay. Let's take a look. So now you'll notice there's this field here. Let's drag it in. We have an error. Okay. So we just replaced our instances of SR with our beat border. And yeah, there we go. All right, let's take a look. Okay, that's not what I thought would happen. Not what I thought would happen. Let's see here. So we have this guy, and we should be changing the alpha of this, but it's not quite doing that. Oh, right, it's being reassigned right here. So it's just ignoring what we gave it, and it's reassigning and start. Okay, if we remove that line, we should be good here. There we go, cool. Okay. So I don't want it to just fade to nothing. I actually want it to, let's make this public. We don't really need it to be, and now we can set it manually. Because basically what I'm doing here is faded color. It's just taking the original color and setting it to the transparent version. So I don't want to do that. I want to change it from, we'll just do it from green to red now. That's kind of like a standard like good to bad scheme. Let's do that. Make sure your alpha's up here, otherwise it's going to be transparent. And we can use this color picker tool to get the initial color. We'll just set it to red. Now while we're at it, we also want to change the scale of bead border. So let's do that. We can just use some vector 3s to keep track of our scale. So let's just do vector 3 original scale. We'll do private vector 3 end scale, maybe we call it. Now our original scale is just going to be our bead border dot transform dot local scale, and then our end scale. Now let's see what the end scale actually should be. We actually might change this. We're going to do a new vector 3 because we actually want it to start out bigger than what it is originally, and then we can have it end at the end scale, which is actually what its local scale is. So maybe let's rename this to start scale and then end scale. Now going back into Unity, if we're not going to make any changes here, we're just going to kind of see what this looks like. 1.2, 1.2, as you can see, is already fitting. So maybe you can start from 1.5, 1.5. Maybe using something like 2 and 2. Let's do that. Let's do 2 and 2. So our start scale is going to be new vector 3, 2f, 2f, 1f. And then our end scale is just going to be what our start scale is, so we don't really have to worry about this. Now when we do our lerp, we can also change the scale as well as our color. So thinking about how to do this, we can kind of use the same logic, probably. But instead of color.lerp, we're just going to do vector3.lerp, and we're going to go from start scale to end scale. So we already know that when I is 1.5, this is going to be 1. So at the end of our color fading, we're also going to be at our end scale. And the last thing we need to do here is just actually change bead border.local scale to start scale. So it's start at larger scale. I hope we don't see any like blinking here, where it's like in the first frame it adjusts the scale, but we'll try it out. So here I'm gonna go back from the prefab without saving any changes, or I guess just to be more explicit, we can just do this, but I can just discard changes here. Okay, let's see what this looks like. Oh wow. Oh, that's interesting. So it looks like this is kind of an interesting effect, but I don't want it to continue past the scale. So it seems to just keep going, which is kind of strange. I wonder why. Because after 1.5, it should finish. Ah, okay. It almost seems like this is going beyond 1.5 because the end scale should be the local scale. So let's take a look at what's actually happening here if we pause. Okay, so you can see it's going to 0.4 for some reason. So it's like it's not being clamped. Like the coroutine almost keeps on going here, which is sort of strange because it should stop after I is 1.5, and when I is 1.5, this will be 1, and then the skill is going to end. Huh. Let's see. I wonder if like this coroutine is being called more than once, or somehow I is being exceeded, and the statement is never ending. Let's see. Yeah, the skill is going down to 0. Is there a clamp? Lerp. This should already be clamped because there's a lerp unclamped here. Alright, let's we're gonna make these public. I'm guessing something weird is being set with end scale. So I'm just gonna make these public just so I can see what's actually being set as these values. Let's pause here. Ah, end scale is 0, 0, 0. Yep, that will do it. So apparently, end scale. Well, now why would that happen? Because it's being set as a local scale. That's so it's still happening 1.5 seconds, but our end scale seems to be 0 for all of these. End scale, end scale. Scale. This is a bit weird. Let's check our prefab. Okay. Yeah, it should be 1.2. Start scale. Alright. I'm not sure why that was being set to 0. Let's explicitly define this as 1.2f. If you guys know, put it in the comment below. I'm sure it's something dumb. I'm doing something stupid. Start scale. Alright, let's see what this does. Let's see if this fixes it. That is weird. Is it because it's a local scale thing, maybe? Anyway. Yes, okay, this is more like it. I will say, though, I think I do want it to ultimately be transparent. So let's fix that real quick. We'll make fed the red color. So we'll have it fade to red and have the red fade. And then we'll also have the fill fade as well. So let's define a color here. Fill fade. I hate this boilerplate. Well, maybe you'll figure it out. Okay. Sure, good enough. And then we'll just have, so this is our fill fade, so we'll also have the fill.color equal how do we, let's keep the original color fill color is equal to fill.color. Okay. And we're just going to go from fill color. So basically what we were doing before. To fill fade. And then I divided by 1.5 f. Why doesn't it like this? Fill color does not exist. Yes. Let's define it up here so we have access to it in the lower scope. Okay, that should do it. Let's see what this looks like. It's kind of messy because I'm defining some colors in Inspector and some colors in code, which I don't think is great practice, but we can always fix that later. So let's take a look here. Oh, yeah. Okay, let's fix that. We never assigned our fill here. So our fill is just going to be the beat itself. Let's assign that in our prefab, go back, and try it out. Okay, so it's starting from, okay, interesting effect, but it seems that the original color is being overwritten here. Fill color. Okay. You know what? Let's just be very explicit about this and do what I should have done initially, which is just declare these in Inspector, so there's really no ambiguity here. Okay, and then we can just sample this, pump up the alpha, and we're just going to take the sample, and the alpha is already down for that, as you can see because of that little white bar. Save, and give it a try. Okay, nice. That's pretty good. Still missing the little something, but maybe the blue could also change color to red. Let me just see what that looks like real quick. I'm just curious. That way they'll probably seem to kind of merge as they approach the end. The blue and green both converge to red, and that might be an interesting effect. Okay, kind of like that. There's a little gap at the end, which is kind of annoying. You could probably fix if I just change the N scale to something like 1.15, then we'll kind of start to, it'll overlap a bit, and we'll probably get rid of that gap. Now, real quick, before I finish the episode, we've already gone long enough. And there we go, it seems to just merge. But I don't like how it gets destroyed. It's not getting destroyed, it's just fading out, right? It almost seems to like blink out all at once. Or is that just me? Yeah, it becomes red. And then it disappears. Okay, so something is being weird here. So if we go from 0 to 1, the faded colors should all have the alpha. It's almost like the sprite render is kind of being weird. Fill fade, faded color, alpha 0. Alright, let's take a look. Again, we'll pause in the middle here and see what's happening. It looks fine here in our scene view, which is kind of strange. In our scene view, you can see Color is starting to go. It's almost gone at this point. Is this just an illusion? It almost seems like here, if take a look at this, this doesn't look like it's fully faded. It looks like it's still mainly there. But according to Unity, it is mainly gone. Now, it might be just this black background. That's kind of causing it to appear that way. Because the black is causing it just to appear more bright. Yeah, that seems to not be as much of a problem. So that might just be some sort of visual illusion. I kind of like, let's try like just gray. Like maybe try like a bright gray for now. Yeah, I like this better. I think this is less, definitely hurting my eyes a little less. Okay, this is a cool effect. Okay, so last thing we're going to do is we're going to calculate a score when we actually hit these things. So we already have our start scale and end scale. Now we're going to, first of all, we're going to destroy the game object when we click it. Actually, let's save this for last because we're gonna, if we destroy the game object, we destroy the script along with it, and so we'll do that last. Now let's calculate our float score, and we're just going to grade it from 100, from a score of 0 to 100. Does that make sense? Well, there probably should be some forgiveness, but we'll just do 0 to 100 from now. And we'll just say early is 0, on time is 100. And we'll say score equals, let me think. So if it's near the start scale, we kind of have to calculate the distance between the start scale and the end scale. So let's take the transform dot local scale. What if we can do like a vector3 dot or a float dot lerp? Does this make sense? Maybe we can do, yeah, vector3 dot distance. Okay. We'll get the distance between the transform dot local scale and end scale. So this will give us something like anywhere from 1.2 to whatever. Let's say it's like 1.5, 1.5. It'll probably give us something like, it's going to give us one number actually, which is kind of interesting because it just gives us a float. Now, if we do something like score, if we normalize it, let's try this out. We'll take this distance and we'll normalize it. Well, distance might already be normalized. Okay, let's normalize this and normalize this. I think we have one too many things here. And scale dot normalize. Vector3 dot distance. I think I messed up my parentheses here somewhere. Alright, so we have this is one parameter, this is 2. sec. Okay, this, I think you're supposed to use dot normalized here. There we go. Yes. And one more parenthesis. Okay, good. And we'll just say score times equals 100. And let's output our score here. So basically the reasoning here being the smaller the distance, the closer to the n scale, the higher score, because if you have something which is close to the n scale, you're going to have a small distance between the local normalized scale and the normalized n scale. But I'm kind of spitballing here. Luckily, we can just try it and see what we get. Let's open our console here. Oh, okay. We're not able to click anything. That's fun. So we're not getting anything on mouse down. I wonder why. Maybe, I think let's check our old, luckily we have our old prefab. And we have no circle colliders, so that'll do it. Let's give a circle collider to the sprite renderer. I think this should be fine. Let's check the radius out. Okay, it's not really showing it. We'll just give it a radius of 1 for now. I wonder if my gizmos are off. There it is. Alright. Yeah, my gizmos are not showing. So, as you can see here, a radius of 0.5 seems to do it. So you'd think this would be a radius of 1, but whatever. Alright, let's try that again. Yes, perfect. So you saw that was a... Okay. We seem to be getting the same thing the whole time, which is kind of funny. So clearly, we're not calculating something right. Either that or I'm just very consistent. Obviously not. Alright, let's see what's going on. So, probably here I should be using the beat border instead of the transform itself, because, well, actually, isn't the transform the beat border? Let's see. No, yeah, so I'm using the beat. Of course, the scale of the beat will never change. So what I meant to use here was the beat border. I probably don't need this twice. I don't know why I still have this. So let's get the beat border dot transform dot local scale. And that should work better. So before I was just getting the scale of the fill. So obviously the scale of the fill isn't changing, so we're going to get the same thing every time. Okay, there we go. Excellent. So it's kind of it's roughly corresponding. We probably could change this algorithm up, but you can see here as we get closer, it's approaching something like 95, 96, 97. Yeah. There we go. So probably what's happening is we almost got 100 there. Probably need to change the alpha, since when it's transparent is actually when you want to hit it. So changing the way that blends is probably going to be our next step. Oh, 99.5. And the other part is our distance is never going to be that high. So it's almost like we need to change our baseline. Because the distance between when it starts and the distance between the end scale basically the lowest score you can really get here is probably going to be, let's see if we can find out. Yeah, it's an 87 or an 85, I guess. Probably like an 85. So instead of really, I'm not going to think too much about it. Let's kind of just do, if we know that it's 85, then this is probably 1 minus this. It's probably, this is only 0.15. So we can kind of say this goes from 0.15 to 0. So instead of doing this, let's just do 0.15 minus this. And then if we multiply this by 100, so our score will be 0 when these are equal. Oh. Okay. This is a lot of math. Let's see what happens. Okay, so now we're getting about 10. And if you click early, okay, negative score, that's not good. Right. I'm probably going to have to think about this a bit. Let's see. Yeah. If we do 100 times 0.15f, we're essentially going to be multiplying it by, we're going to be kind of rescaling it. So this is what, multiplying by like 600 approximately? Let's do this. And again, this is definitely not an exact method. But just so we have something, and probably for next episode, I'll take a more mathematical approach. Okay, so I think this kind of, yeah. Okay, that kind of does it. Decent job. So you can see our bad scores are like 52, 74. I think I got a 29 there. So I could probably just measure, you know what, whatever this value is, the 0.20f, we'll just call that our float offset, or float basis. That sounds cool. And I think this float basis is just gonna be whatever this is. Specifically our start scale. And we could probably just, okay, I think this works. Because we're using our start scale to kind of calculate that bias. You know what? Bias. Yes, perfect. That's really what I'm looking for. Missing a semicolon somewhere, of course. And now, because this is kind of being a little more mathematical about it instead of just guessing numbers. So our bias is going to be the original distance between the start scale and the end scale. Yeah, there we go. So that was 82, 94, and it should be almost 0. Of course, I'm never going to get it as soon as it spawns. See, there should be a grace period probably where it like kind of goes beyond it, but still doesn't like completely turn invisible. So I'm gonna have to mess around with those values a bit. But it's kind of nice. It's already kind of like fun, I think. The scoring seems to be somewhat 92, 99. Yeah, you need to click it when it's almost transparent, which kind of makes this a little tough. Anyway, yeah, what a long episode. 40 minutes. If you stuck all the way through, thanks. I'll probably put a disclaimer to kind of, feel free to skip through because there's a decent amount of me figuring this out. But hope you enjoyed it, had some fun. Alright, see ya.